Alright, for recording number 3 here, I want to get into the meat and potatoes of the class, which is to cover statistics. I made up a term there, statisticsophobia, for Roman numeral 3. Statisticsophobia is a term I made up basically describing the fact that people are usually scared of statistics. My goal is to get you not to be scared of statistics. That's the main goal of this made-up term. So let's pretend that we're doing a little study here. You'll want to take some good detailed outline notes, and when you type this outline up, basically what I'm looking for is not just a note section, but kind of a formalized detailed outline. You'll send me drafts of this so that you can hopefully get it into shape. The question here, let's say a researcher wants to know if students are scared of statistics. So let's say I collect some data, 90 are scared and 10 are not. Now when you look at that data, you probably think, well, yeah, that's going to be a statistically significant difference. The statistic we would do on this is from chapter 17 of your book. It's a chi-square, which was also on the discussion board. It's a chi-square because we're working with frequencies. We have nominal categories, being scared or not being scared, and it's just frequency based. The formula that we would use on page 598 of your book is the chi-square goodness of fit formula. And for that formula, I wrote out the terms there. You can write it out yourself and kind of describe it. FO minus FE squared over FE. So the first thing you'd have to figure out is what do all those FOs and FEs stand for? FO stands for the frequency observed. That's the frequency you collected in the data. Do you know what the FOs are in this case? The numbers are the 90 and the 10. So FO is 90 and 10. FE is the frequency we expect due to chance. You'll hear me say that term a lot, due to chance. If we collected the data with the 90 and 10, the way you would figure out the FE is you'd have to say, well, how many total do we have there? Well, the N is equal to 100. And if we have two categories, if there is no difference whatsoever, the FE would be 50. Because 100 into two categories, scared and not scared, is 50. So you'd have to do out the computation there, the summation of, what would it be? 90 minus 50 squared over 50 plus 10 minus 50 squared over 50. And if you do the computations on that, you can send me a draft. I'll give you a little clue that the result of that will be a Beatles song, and will also be the year that I was born in. So see if you can figure that out and send me drafts of that. Number 2, we'd have to figure out, is this result statistically significant? So the way you figure that out is you have to look in your book. Let's see if I can turn to the page. Page 711, I think, is the page. There's a chi-square table in there, and you'd have to go to the column that says 0.05, and then the degrees of freedom here, you have two categories, so you have 1 degree of freedom. So you'd have to look at the critical value there for 1 degree of freedom and basically figure out that with 1 degree of freedom, 0.05, the critical value is 3.84. If you're over that, you're significant. Hopefully you'd figure out that you are here. You'd have to write this out in an APA way, chi-square, and then in parentheses, degrees of freedom, 1, n, you have 100 there, and equals your chi-square value, and since it is significant at the 0.05 value, you'd write p less than 0.05. So see if you can write it out, and then for assignment 4, see if you can do the same thing with 51 versus 49. Hopefully you'd figure out that that is not statistically significant, and you'd write out the chi value, and then you'd write p greater than 0.05. So take a shot at that, see what you can do, and that should cover it. Thanks. Bye-bye.